Today we're going to talk about compound interest and APY, which stands for annual percentage yield, and how that compares to APR, which is an annual percentage rate. I'm going to start with compound interest. And compound interest has the illusion of having two different formulas. It's really one formula that has a little bit of a change because of the type of compounding that will take place. Most of the time, especially in real-world examples, we're looking at this one over to the left, where we have A equal to P times the quantity 1 plus R over N raised to the NT. P stands for principal. That's how much money you're going to start off with in the account. N is the number of compounds, and this can vary quite a bit. You can talk about monthly, so you would be compounding 12 times a year. You can talk about quarterly, and so that would be compounding 4 times a year. There can be weekly, although that's less common, 52 times a year. You can have daily, so 365 times a year. And you can also have semi-annually, which was twice a year. Sometimes they also talk about that as being biannually. And if you're talking about compounding annually, then you're really talking about a simple interest that repeats, but you can have annually where N would be once a year. R is your rate as a decimal, your APR as a decimal, and it's very important that you change it over to a decimal. T is always time in years, even if you're talking about a portion of a year. So if you want to invest funds for only 6 months, you don't want to say 6 because that means 6 years. You'd have to say 1/2 or 0.5 to talk about half of a year. And A, the amount that you simplify for, will be the amount in the account in T years. Now, if you have a situation where you're compounding continuously, this is not something that we usually see when we're talking about money, but more when we're talking about growth rates in nature. Then you'll have to use the number E, and the number E is about a 2.718 ... It is irrational like pi, so it never ends and it never repeats, so we use 2.718 as our estimate. Of course, we have an E button on our calculator, and that will be very helpful, as you'll see in a few minutes. P is still principal, R is still rate as a decimal, T is still time in years. What happens is that 1 plus the R over N kind of gets eaten up and turned into the number E. A is still the account in T number of years. Let's look at an example of how we can compound the same amount of money in a few different ways, and you may be surprised to find out which is the best deal. So I have $1,200 to invest. I want to invest the funds for only 5 years. I have the following accounts to choose from. Which one has the highest yield? So for these first 5, we're going to use A equals P times 1 plus R over N to the NT. But for this last one where we compound continuously, I'm going to use P E to the RT, also sometimes we just call that PERT, right? Because that's what it says. And I'm not going to find these numbers by hand. I'm going to use my calculator, and I'll show you a few cool little features so that you don't have to type the same thing in over and over again. I have a principal of 1,200, so that's P. These will be all of my different R's that I'll need to change to decimals. This is where my N is coming from, and I am talking about T being 5 years, so at least I don't have to worry about a portion of a year or a fraction or a decimal of a year. And I'm going to bring up my calculator, and I'm going to start to type all of this in. So my first one, I have 1,200 times 1 plus my rate. Now if I change that percent to a decimal, I get 0.023 divided by N, and if I'm compounding yearly, that's once a year. I don't really need to write the 1, but I'm going to show you a cool little trick where we can overwrite some of the other things that we've typed in. So I'm going to go ahead and type that in. Raised to the N times T. Now, if you have an older version of the calculator like I'm using, you're going to need to put your exponent in parentheses. If you're using a newer operating system on your calculator, you'll actually be able to see what parts are in your exponent and which are not. So it's the parentheses are less needed because the calculator can tell what belongs where. But from the older version, I'm going to have to say n times t and put that in parentheses. And in 5 years, I'll have $1,344.50. So 1344.5, and I'll jot that down right there. That's yearly. I'm going to get this out of my way so I have some space to write the next ones. So now I want to find semi-annually, and I want to do so with a different rate. So I don't have to type it all in again. I'm going to hit second, enter, and the last thing that I typed in will come up. Now I can arrow over the pieces that need to be changed. My 2.3% becomes a 2.1%. My once a year becomes twice a year. And I'll need to change that in my exponent as well. And now when I hit enter, I get 1332.12. So this would be 1332.12, already better off sticking with the annually compound. Let's check out quarterly. I'll do second, enter again. Change my rate from 2.1 to a 2.4. Quarterly is 4 times a year. And I will change that over in here as well. And I hit enter, and now I get 1352.51. 1352.51. Notice that the numbers, although they clearly vary, there probably will not be a huge difference between the numbers. In order to generate a large difference in the amount of interest that you accrue, you have to have either a much different principal, so one's really small, one's really big, a very different interest rate, so 1% compared to maybe like 5%, or it has to be in much more, in for a much more longer period of time, so not 5 years, maybe one's 5 years and one's 50 years. If you're talking about the same amount of money for the same amount of years, where the interest rates are pretty similar, there'll be a difference, but it won't be a huge difference. Let's look at monthly. Second, enter. I'm going to have to rewrite some of this because now I have a 2.2, but my 12 will overwrite some of it, so I'll have to rewrite that last piece again, 12 times for 5 years. 1339.40. Quarterly still our winner. Let's look at daily. 2.0, 365. Again, I'll have to type this over a little bit. 365 times 5. 1326 and 20 cents. So far, quarterly appears to be the winner. But let's go ahead and check our compounding continuously. P times E, which will be second ln, our rate, 0.018 times T, which is 5, and that one is 1313.1. Oh, the least of them all, 1313.01. So even though you're going to be getting more compounds with the continuously, it's not so much that there's a smaller rate. It's that this portion of the rate is being distributed amongst an infinite amount of compounds. And so it may seem like a good thing to have as many compounds as possible, but that also means that you're not getting as much interest each time. And so time, as in years past, is going to really be the player that creates the most interest for you. So our highest yield is our quarterly. 2.4% compounded quarterly will give me $13.52, so that's where I'm going to go ahead and put my money in. Now, when you go to the bank to put your money in the account, they're going to give you a variety of numbers, and one of those numbers will most likely be APY. APY is annual percentage yield. It is the percentage rate that you would need to have on an account if it was compounded using a simple interest to get the same amount of interest that you get from the compounding account. So I want to make $13.52. I want to make just over $152 worth of interest over the 5 years. What rate on a simple interest account would I need to have so that it didn't matter which account I put it into? These numbers tend to be relatively close together, and the banks will give you both, and you can see for all the ones on this page that I happen to pull out, they're the same. The rate, the APR, and the APY tend to be the same, or at least very close to being the same, and the difference will be much further out in the decimal. So not 2 decimal places, but 4 or 5. But we're going to look at our compounded quarterly, which was 2.4, and we're going to try to figure out what is the APY on that account. So the APR was 2.4. We're not going to actually use the numbers that we used and found in the last equation, the 1200 and the 1352, to simplify the process. What we're going to do is that we're going to pretend that our principal is $1 and that our time is for 1 year. And I'll just make our numbers a little bit neater in the end. You would find APY by subbing in the $1 for the P and the 1 for the T in both of the equations. Now, which one you use depends on what account that you're talking about. But if you're talking about an APY, you're talking about money. And so this E1 will be highly unlikely. I don't think you're going to find a bank to compound your money continuously. And so we're going to use APY. 1 plus r over n to the n, and then we're going to subtract out this 1, and that will make a little bit more sense in a minute. So my rate that was on the quarterly account was 2.4, and so my APY is going to be 1 plus the 0.024 over 12 to the 4, because it's quarterly, to the 4th power. And then I'm going to subtract out this one that is in here, actually, at the end, but I need to do this first. So 1 plus 0.024 divided by 4. Let's raise that to the 4th power, and I get 1.0242, we'll say. Subtract out the 1. And we get an APY of 0.242, which of course as a percent is 2.42%. They tend to be very, very close together. They can be the same thing. They can be different depending on how much money and how long, but they do tend to be pretty close to the same thing. And so that's how you use your compound interest formulas and find APY.